So we know that, I'm going to rewrite everything. Well, actually just on the left side. So we know that cosecant is 1 over sine. So I'm going to do 1 over sine. And then I'm going to do the same thing for cotangent. So I know that cosine is going to go on top. And then sine is going to go in the denominator. I'm just going to keep the right side the same. So we know that they have the same denominator, so we're going to combine like terms. Is that the word? So I'm going to combine 1 minus cosine, and then we have the same thing in the denominator, which is equal to 2 cosecant squared. And then what we did, we recognized that 1 minus cosine to the power 4 theta can be split up into 1 plus cosine squared of theta.
Called the difference of squares. Goes back to what you learned freshman year, but applying it to trigonometry.
And 1 minus cosine squared theta. So if you were to FOIL, you would get this. And then we know that based on arbitrary identities, 1 minus cosine is equal to sine squared. So we're going to substitute.
Paper in a little bit so we can see. There we go. Now tell us again.
We know that one of these that we have right here, this one, is 1 minus cosine squared can be equal to sine squared. So I'm going to substitute, and Darian's going to take over.
Where were you? You're going to substitute this into the equation. So we'll have 1 plus cosine squared theta and sine squared theta over sine to the power of 4 theta. And what we can do is take out sine squared from the bottom. Oh, okay.
And before you go any further, I'm going to stop for a second. I'm just going to kind of recap what you've done because it's a lot. This is the hardest problem you're going to see today. Okay, so we rewrote cosecant as 1 over the sine. Cotangent is cosine over sine. You guys are doing a wonderful job. I can see I have a common denominator. And then I recognize this pattern, which is the difference of squares. So 1 minus cosine to the 4th is 1 plus cosine theta times 1 minus cosine theta. Okay, and then you recognized using this that 1 subtract cosine squared theta is equivalent to sine squared theta. That's why I ended up getting rid of this quantity and replacing it with sine squared. Again, he's taking sine to the 4th theta and breaking it into sine squared and sine squared. Okay, keep going.
Okay. We can take sine squared off from both sides, from the top and bottom, and we'll be left with 1 plus cosine squared over sine squared. And we can distribute the sine into both the numbers on top, so it'll be 1 over sine squared plus cosine squared over sine squared. And we know that this is, I can't see that part, what is it? Cosecant squared plus cotangent squared. And we know that using arbitrary identities, we know that cotangent squared can also, the equation for this can be manipulated to.
So we're taking that second trig equation, and he's saying we're going to manipulate it. It means we're going to isolate cotangent squared. So we're going to take the 1 and move it to the opposite side. So cotangent squared theta, he's doing an excellent job of explaining this, is equal to cosecant squared minus 1.
We can replace cotangent squared with cosecant squared minus 1.
So now we're taking out that cotangent and replacing it with cosecant squared minus 1.
And from there we can add these two together since they have the same bases, right?
Keep going.
Thank you.
So we have two groups of 2 cosecant squared theta minus 1.
Which is equal to the equation on the top.
And that's exactly what we wanted to have on the right-hand side. So now we have the left side is equivalent to the right side, and that's our whole goal with verifying trig functions.